Hello, this is question 15 on your AQA sample paper 2. At time t0, a parachutist jumps out of an airplane that is traveling horizontally, and the velocity v is given by this vector. The unit vectors I and j are horizontal and vertical, and assume that the parachute is at the origin when t is 0. Model the parachute as a particle. We have to find an expression for the position vector at time t. So we have our coordinate axis, x and y, and a parachute is jumping out of an airplane here, and then doing something. We are not very sure. We need to find, when the parachute is here, the position vector. So we need to find this r from the origin, yeah, this vector. We have the function velocity. Function velocity, or the vector velocity, is this one. So 40 e to the power of minus 0.2 t and 50 e to the power of minus 0.2 t minus 50, and just multiplying, expanding the brackets, I think is going to be easier to see. Yeah, this is the velocity. Remember, when we have variable acceleration, we have position vector, velocity, and acceleration. We differentiate in this way, we integrate in this way. So if we have the function velocity and we want the position vector, we are going to integrate. Yeah? So I'm going to integrate velocity to have my position vector. To integrate vectors, remember, I just integrate each of the components. So I'm going to integrate each of them. So this is going to be the first one. To integrate this function, I have the 40, and then I'm going to divide by this, and this doesn't change. So it's 40 divided by minus 0.2, 40e minus 0.2t divided by minus 0.2, and the other component is going to be 50e to the power minus 0.2t divided by minus 0.2 minus 50t, and then I have a constant of integration, so I can add each of them. So plus constant of integration plus constant of integration. Yeah. This is minus 200 e to the power of minus 0.2t, and the other one is minus 250 e to the power of minus 0.2t minus 50t plus c prime. And now we know that at the beginning, parachute is at the origin when t is 0. Yeah, so when t is 0, position vector is the 0, 0. So when t is 0, position vector is going to be 0, 0. So I have that minus 200. When t is 0, this is 1. So I have minus 200 plus c is going to be 0, which means the first constant is 200. And then the other one is minus 250. When t is 0, this is 1 and this is 0. So minus 250 plus c prime is 0. So c prime is 250, which means now I have an expression for everything, which is the position vector is this one here, but I'm going to write the constants now. So 200 minus 200 e to the power minus 0.2 t, and the other one is 250 minus 250 e to the power minus 0.2 t minus 50t. Yeah, that's my position vector. You can write this way, or you can write with the other notation. So if you write with ij notation, you will want brackets, because all here is multiplied by I, and all the second term is multiplied by j. Yeah, so don't forget to write your brackets, minus 50 t j. Yeah, that's your vector. In general, yeah, so for time t. Then the next thing says, the parachutist opened her parachute when she traveled 100 meters horizontally. find the vertical displacement of the parachute from the origin. So when C has traveled 100 meters, we need to know the vertical component. So the parachute will be here at one point, and we know the horizontal component of this vector is 100, and we want the vertical component. It's just the only thing that we need. So we are going to use this expression, and we are going to find it out. So horizontal component is going to be 100. So the 200 minus 200 e to the power of minus 0.2 t is going to be 100, which means 200 e to the power minus 0.2 t is going to be 200 minus 100, 100. So e to the power of minus 0.2 t is going to be 1/2 or 0.5, and then taking ln, minus 0.2 t is ln of 0.5. Therefore, t is ln 0.5 divided by minus 0.2. This is 3.46. I'm going to keep all the number in the calculator. And this is when she opens the parachute. So now we have to find what is the vertical displacement for this time. So I'm going to substitute that t into the j component. So minus 250 minus 250 e minus 0.2 times 3.46. Remember to keep all the decimals in the memory of the calculator so you can run at the end. This is minus 48.286 meters. So do we have to round to anything in particular? Vertical displacement. They give us a whole number, so I wouldn't round. So let's say minus 48 meters, yeah, to two significant figures. And the next part says, carefully explaining the steps that you take, deduce the value of G used in the formulation of this model. So we have parachutes that jumps out of the airplane that is traveling horizontally, and that means that it has no vertical velocity, and the acceleration, remember what I said at the beginning, so we have displacement, velocity, acceleration. When we go this way, we integrate. When we go this way, we derivate. So if we want to find the acceleration, we will need to derivate the expression. But we know we don't have horizontal acceleration, yeah, in projectiles question, we don't have horizontal acceleration because we don't have any horizontal forces acting. So the only one that we are counting is the vertical one, the vertical component. So the acceleration will be something like 0, the horizontal, and then we integrate the vertical. So the vertical is going to be integral of this one. So I'm going to copy that. So 50 e to the vertical component of the velocity is 50 e to the power minus 0.2 t minus 50. Minus 50. And I'm going to derivate that to find the vertical component of the acceleration. When I differentiate that, I have 50 times minus 0.2 e to the power minus 0.2 t, and this bit is 0. When t is 0, so at the beginning, when the parachute is jumping, the acceleration is going to be minus 50 times 0.2, so minus 10. So we are using gravity as minus 10 meters per second, which is very close to what usually we use, yeah, the 9.8. And this is acceleration that I'm using, and it's negative because it's down, and we are considering the ij, yeah. So remember, we are considering ij, so this is really j, so I should write the j. Meters per second. And that's all with this question.